Pocket Circuit CA is an app designed to help first and second year undergraduate engineering students enrolled in EK 307. EK 307 is mandatory for all undergraduate engineering students at BU and is the Introduction to Elementary Circuits class. The problem with this class is that it has a very intensive lab section, but the lab section doesn't answer a lot of basic questions about equipment usage and theoretical calculations, which can be very frustrating for the students and for the TAs who have to answer a lot of questions repeatedly. So we decided to create an app that helps solve a lot of these issues. The app is very user-friendly. It opens up to a list of all of the labs, and once you select a lab, it presents a page with a list of tools specific to that lab, specific to the BU Circuits course. So by clicking on Lab 0, we have several options. You can click on the multimeter diagram, which presents a diagram with labels and hints as to how to use this equipment. And all of these diagrams were either custom made for the app or provided by the lab course here at BU. And when you rotate the screen, the image doesn't rotate so that the picture is not distorted. We also have a similar power source diagram and our first calculator, which is the V equals IR calculator. Here, the user inputs 2 out of the 3 values, and the third value is calculated. Each of our calculators also has error warnings, so it prevents you from putting in too much information, as in putting all 3 of the values, or too few information, too little information. And it also prevents you from including negative resistances, but it does permit negative voltages and decimal values. And each result can be put into scientific notation if the result is sufficiently large or small. Lab 1 also includes the VIR calculator and the multimeter diagram, but this time it also has an LED diagram because this is the first time the students encounter LEDs, and it shows the polarity of an LED, which is a question that UTAs get a lot. And it also includes a breadboard diagram. Lab 2 includes a voltage divider calculator with a custom diagram and an equivalent resistance calculator, which we will use for our first demonstration. Here you can put in R1, it can be a decimal value but not negative, and R2 here can be 5. And depending on the button you click, it can give you parallel equivalent resistance and series equivalent resistance. Lab 3 provides a custom diagram describing Thevenin's theorem and another VIR calculator. Lab 4 includes a potentiometer diagram, which shows the pins of a potentiometer and exactly how to use it. And it also includes an op-amp pinout diagram, which is custom made and is useful because the diagrams that you often find on an op-amp datasheet can be too complex and really confuse students. We also have a non-inverting op-amp calculator. For our op-amp gain calculators, if it will calculate the gain if R1 and R2 are provided, and if V in is provided, it also calculates V out. Lab 5, the new tool here is an inverting op-amp calculator. Here we will do a demonstration, so we can put in a negative voltage, 5.5. Our in here can be 1, and RF can be 2. And as you can see, it calculates both gain and V out because we included V in here. Lab 6 shows a TI launchpad diagram, which again can be rotated. Lab 7 includes an RC time constant diagram and the very similar RL time constant calculator. Lab 8 includes the critically damped resistance calculator. And Lab 9 includes a passive filter cutoff frequency calculator. We think Pocket Circuit CA is very user-friendly and will be helpful to instructors, undergraduate TAs, and especially to students. Thank you.